All right, welcome everybody to the August HPC Best Practices webinar. Today we're going to hear from Brigitta Sipőcz, who will be speaking about user-facing tutorials as code, reproducible and reliable tutorials with CI/CD. As always, we want to hear from you as we go through the webinar. So we have a Google Doc at the link here on the screen, and I'll be putting this in chat, that we encourage you to note down your questions, and we'll ask those as opportunities arise during the presentation. We also request your feedback. We have a very brief survey, just a couple of questions, and we would appreciate if you can take a couple minutes after the event to fill it out. We will be recording this and making the slides and the recordings along with the Q&A notes available, so everybody who registered will get an email about this when this is available, hopefully in about a week. And please feel free to share with your colleagues who might not have been able to join. You can always find these materials and other webinars in this series at the ideasproductivity.org site, and you can see the path to get there. And with that, I'm going to turn it over to Brigitta.
Thank you, David. So thank you very much, and thanks for coming and for the opportunity to talk a little bit about tutorials and tutorials as code. So I was asked to do a very short introduction. So I'm Brigitta Sipőcz. I am an astronomer turned research software engineer. I am staff at Caltech at the NASA IPAC Infrared Science Archive. I am a Python community open source maintainer. I'm involved in maintaining projects in astronomy, but also more generic usage projects such as NumPy tutorials, the scientific Python project, and in astronomy, AstroPy, AstroQuery, and about a dozen other, mostly infrastructure projects. I'm also organizing conferences and developer meetings for the Scientific Python Developer Summit and also the SciPy conference for Scientific Python. And outside of work, I love spending time out in the mountains, especially in the winter. Okay, so let's jump into the talk. My talk will be divided into like two sections. So 2/3 of big picture overviews and concepts, and then the last third will be showcasing the usage, how we do what I'm talking about at IPAC. And it will be, the demo will be with screenshots, but I'm also, I have the deployed sites and everything opened up in my browser, so happy to go into specifics during the Q&A if anything comes up. Okay, so I would start with explaining what I mean by the title. So first of all, what I mean when I say user-facing tutorials. So I mean openly available documentation for various resources, such as libraries, APIs, data archives, that includes fully working code examples. So during the talk, basically everything can be very language agnostic, but I'm drawing experiences for maintaining 3 different point of view types of tutorials. So first of all, tutorials for library usage. These are very closely coupled to the libraries themselves. So this is when I'm using my hat as a NumPy tutorial maintainer. Then I'm also speaking on behalf of what we do in a lab, in a more specialized setting where we are using multitudes of libraries together to showcase how our API, how our data can be accessed and used by end users. So for here, I'm talking about, I'm using an example for the ERSA tutorials, which is to provide, showcase how to use and access data at the NASA Infrared Science Archive. And I'm also using examples and point of views as a library maintainer, but it means these end-user facing tutorials for the library maintainers themselves. When I'm talking about tutorials, I'm basically meaning all these 4 flavors of resources that are in these diataxis categories. They are called a tiny bit differently at different places. So my key point here is that I'm talking about resources with fully working code examples. Many things that I'm saying here and many of the tools I'm showcasing can be used for a more simplistic cases when it's about a website and then how to maintain a Markdown-based website. But when I'm saying tutorials, I'm really focusing on code examples that are focusing for that are aimed at the end user. And what are these flavors I'm thinking about? So first of all, I'm thinking about context in the context of async learning. So these tutorials are provided async in a website, in a repository that the users can access at any time. We don't have very strict restriction and expectations from the users. They can come from anywhere. So in this case, we are showcasing how to use NumPy, how to access NASA data at our archive. So we are not restricting the users to be working on a very specialized environment and with a very specialized Docker image. Then the second big use case for tutorials that I'm not really covering because it's a much easier use case is when you are writing and maintaining tutorials for synchronous learning, typically like workshops and courses when there is an instructor and you expect all of your participants to follow along. Then you can force them into a specialized deployment. You can expect that they will be running a set of pinned versions of dependencies. So from the maintainer point of view, that's a much simpler situation. So what I'm showcasing as a more generic approach that can be simplified into this workshop settings. And I'm not necessarily talking about these other 2 categories because these are very difficult to cover in CI/CD context and to make them really reproducible. So one case is when you are showcasing a very specialized way of working with data. And I think that this might be the most relevant here for this audience. So when to run a tutorial requires you to be able to log into an HPC system, and it's only expected to run in that system, or when you are expected to have access to very specialized architecture or GPUs. So most of the takeaways I'm saying is not really applicable for that case because there are no resources readily available that lets you test those use cases. And then the first and very important category, but we don't really have solutions for this category, is tutorials or these notebook resources that might be an appendix for a paper. And it would be very important that these notebooks are testable and runnable and reproducible, but it's not clear that who will maintain or if anyone is expected to maintain these resources. So the tools I'm telling you about won't cover this case. Okay, and then the second part of my title, when I'm saying that tutorials as code and reproducible and reliable, I really mean these very, very simple criteria here, but I think it's very important to highlight them because in practice, we are still not doing this. So the first one is in tutorials and documentations, the code examples are working. then the second point, the results are reproducible. I'm not talking about pixel-perfect matching for plots, but if the tutorial, the narrative in the tutorial talking about like a linear fit, then that linear fit is expected to be there. And then really a bonus would be, and that's for reproducibility and for reliability, is an ease of maintenance and an ease of extendability for these resources. So it should be easy to add a new page to that tutorial or a new tutorial to that collection of tutorials, or should be easy to maintain, to jump in and modify a tiny bit in the existing tutorials. So what tools do we use to achieve these? Is first of all, use CI/CD. So use continuous integration and continuous deployment. And for the second one, I'm strongly advocating for using text-based notebooks, and especially a mist markdown flavored Jupyter notebooks. So that will be the use case I'm showcasing, but there are other text-based notebooks and they also have their pro and con. I'm mostly going with the Jupyter ecosystem because it's a community resource. There is no company behind it. There is a community and multiple stakeholders. And I believe that's very important when we are buying into new tools, that there is a long-term reliability in it. So if a company backs out, then the tool still can live on. And then I'm sure it's preaching to the choir type of a situation, but I have a slide about continuous integration. So what I really mean here is that we are running tests automatically for all proposed code changes, or proposed changes in a tutorial. This might also mean checking all the links and references and DOIs. So anything that affects the usability and the user experience. The goal here is to catch the problems as soon as possible. It's not enough to just write a notebook and then add it to your website and forget about it, because ecosystem is always evolving and it's moving, and it's not really reasonable to expect that a code that worked a year ago still works now. And I would advocate strongly for tests as widely as possible for all the supported use cases. And at this point, everything is very language agnostic. So this is the same for Python, but if you have a compiled library that you write a tutorial for, and I assume you already have like tests for that library that test all these supported use cases, different compiler versions that you support, or different operating systems. So I'm only advocating here that do the very same for the tutorials you write. Just plug it into that same system. And so to show what we do ourselves, so we host our code on GitHub. So I'm using everything here is very GitHub specific, but the same can be transferred to GitLab, and the same principles stand there. But the point is that it's an open and publicly available resource, and then we rely on public CI resources as well, because we are reusing workflows, and then we are reusing approaches that other upstream libraries are using. So we are not reinventing the wheel for ourselves. So for CI providers, we mostly use two, GitHub Actions and Circle CI. I'm happy to go into details for these choices. Our code is already on GitHub, so GitHub Actions is really the default to go with. And Circle CI is a smaller provider. It has a really good artifact support. So they will be supporting previews that's really easy to set up and work with. And there are other popular options for documentations and website repositories. So often enough, if your deployment is on Reproducible, especially for libraries, then you use Reproducible also in your CI. And another option is Netlify. It's mostly for websites. Then second point is build a matrix, build a grid for these tutorials, the same as you would do for a library. So if you look at what NumPy is doing, there are a lot of workflows. It's running on all the operating system, different architectures, different compilers, different upstream Linux libraries. And it builds a matrix. It's not testing every possible combination, but it's like setting up a grid. And I'm advocating to set up a grid also for your tutorial. So you're expected to support users on a Windows machine and then run your code, run your documentation on Windows, same as on macOS and then Linux. It's not enough to just render it once and then put it up in a website. And also different architectures and different dependencies and dependencies of different versions of dependencies you are using, including the development version of the dependency. It's very important to catch any regressions before it's been released, because then you can ensure that there won't be a gap when your tutorial is broken, it's not working because there is something released upstream. But also, often enough, you can provide feedback for the upstream libraries if they are doing something that's breaking your code. And I would also say, also test different scenarios. So in my use case, because many of our tutorials are showcasing how to access data at a data archive, then have scenarios when you have internet access or when you don't have internet access. So just make sure that all the scenarios are covered. And then run these tests not just for pull requests and for any code changes, but also regularly as a cron job. And GitHub and Socracy and all these CI providers provide a really easy way to set it up. So be proactive to looking for regressions and for incompatibilities. And of course, if I'm honest here, I also have to mention the typical limitations that all these providers, these are limited resources. So if you have tutorials for GPU access, there aren't really anyone who is providing that for free. There can be memory issues. So all of these CI runners are much smaller in memory than if you go on an HPC system or even go on a larger AWS instance. There can be limited runtime and limited access to data scenarios. So sharing secrets and tokens, it can complicate things. But I would say most of these are just complications. There can be a lot of workarounds set up and set around. Okay, and then with my hat as a library maintainer, all of these downstream end user tutorial testing is super valuable feedback, because typically for a library, we have unit tests, we have really good coverage with that, but we don't really test how a library works together with other end user libraries, especially if we are a foundation library. So NumPy will never test how NumPy works, whether it works well together with a code a PhD student wrote 3 years ago, and then somehow your lab relies on that PhDware code. So at that point, you as an end user or someone who is writing resources for the end user should provide that feedback upstream if there is some problem with upstream. This might be a little bit misplaced, but setting up all of these environments and these developer workflows the same way as you would do for a library, it also provides a lot of resources and materials for your scientist contributors or someone who is not as involved with open source development. to learn how to write good bug reports, how to write good reporting upstream, because you are putting them into the same environment. So it's not emails and then pinging at back channels, but to go through the official pathways. So yeah, so these tutorials are super valuable for downstream libraries. And so the next part of for these tutorials, so here I'm very much talking about Jupyter notebooks, and because whether we like it or not, that's what a lot of scientists are using. First of all, to do some exploration, do some code prototyping. It might be a very messy notebook at first, but by the time they got to end results, and maybe it's something to showcase how to access that data in your lab, or how to use that library as an end user, typically someone will come in, tidy that notebook up, and make it clear, and make it publishable, make it shareable. So for this, these notebooks or this ecosystem is very, very valuable. So we can use Jupyter and Jupyter Lab to develop those prototypes using the notebooks themselves. So the way here is to use those very same tools to then also publish and share a cleaner version. So Jupyter is much more than Jupyter Home and the notebooks. And here I would say that Jupyter Book and the MIST ecosystem is super valuable. So Jupyter Book is like a collection of tools for technical communication and documentation, mostly from the point of view of sharing computational content. And about a year ago, we shipped a new version, Jupyter Book 2, which is using the MIST document engine. So it parses, transforms, and renders documents written in Markdown or in Jupyter Notebook or in a supported notebook format, and parse and transform it into an AST and then renders it into an HTML. It's really fast and it's modern. And using this ecosystem, basically we are buying into something that a lot of other projects are using. And us as end users or tutorial, we can focus on writing the content with render or writing CSS or JavaScript ourselves. So the end result is something presentable. So I'm advocating for using Jupyter Book. A lot of the core scientific Python projects are using it for their tutorials. But there is like gallery of 100 plus. I think it's even above 150 different projects that are using Jupyter Book, either the second version or the first version. And all of these are sharing also a link to the repository, so you can go in there and then look around how they set everything up. Okay, so then I mentioned that maintainability is a very important point. So to achieve that, I'm advocating for the usage of text-based notebooks. And these text-based notebooks are super valuable because it helps with ease of editing and version controlling these notebooks. So the default format in Jupyter is a JSON format. It's very difficult to do anything with it on GitHub. It's not really user-friendly in a way if you're using a text editor to change anything in that notebook. So I'm advocating for using text-based notebooks. It's also coming with a really nice side effect that style outputs are not included in these text-based notebooks by default or by design. And I would say that's a big benefit. It will help a lot with maintainability. with these tutorials, because our end goal is that everything is runnable, everything is predictable. So you don't want to store big binary outputs in there anyway, because you should be able to reproduce those and only do that in the rendering phase. And then I'm with this framework, I'm advocating for using MIST Markdown, which is a superset of Common Mark. And Common Mark is the standard Markdown flavor. And MIST Markdown is developed especially for the Jupyter book and then for the MIST ecosystem. And in this framework, we are using a very simple Python dependency. This is for like rendering. It's called Jupyter-text, and it supports various text formats and provide that glue, that linkage between Jupyter Lab itself and the editable or being able to interact with the text-based notebook. There are plans within the Jupyter project to make the text-based format a first-class citizen in the ecosystem. There is no timeline on it, but there are multiple stakeholders in the ecosystem who are pushing very hard for it, because it will be also very important and useful for interactive Jupyter Lite type systems. Okay, and so now briefly a little bit about what we do as part of the Scientific Python projects and 4 tutorials. So what does Scientific Python do for tutorials? First of all, we have a well-established lecture series. Used to be the SciPy lecture notes, and then we moved it into the Scientific Python project, and then totally refreshed and rewrite it, and then porting it to Jupyter book. We're also very closely working in collaboration with the MIST team to add new features into MIST that supports better websites, themes, and websites, and API documentation features. And as part of my BSSW fellowship, I was also working on SPEC document. It's a Scientific Python ecosystem coordination document. It's a recommendation recommendation document for tutorials of basically what I summarized here previously. And we are also working on an infrastructure repository to be like a supported template for tutorial maintenance, so we don't have to duplicate or multiply the same fixes in all the repos we are supporting. So as part of the Scientific Python, the mission is to better coordinate this ecosystem and better coordinate with the core projects, about 15 highly used core Scientific Python projects. So this is the conclusion for this part of my talk. So practically avoid reinventing infrastructure wheels, buy into an ecosystem that's already very actively used and developed. Use these tools and contribute back, whether it's like your dependency you are having or the infrastructure part of it. But also there won't be one size fits all. So if you have very, very specific needs for a GPU or a very specific HPC setup, this might not be for you. But otherwise, it's really try to think in workflows and automation and in using tools that makes it easier to version control and do a pull request-based development for everything. And so now I would showcase of how this looks like in practice. And it will be like a contributor maintainer experience at our repository at Ursa. And there are any specific questions, I'm happy to jump into the repo and into the rendered version and show around much better than with screenshots. So first of all, I think this is very applicable for many of your teams as well. So we are a small data science team at URSA, and it consists of scientists and engineers. And then we are developing and maintaining tutorials to showcase how to use our data archive. And we are also writing documentations, and we are also writing workshops. Usually these are like a one-off workshop type of scenarios, but we try to write these resources to be reusable, and if it's possible, also share them as part of our tutorial content. And we are also helping scientists to transform their science notebooks to a reusable and preferably a more generic version of resource. I included a couple of example repositories, and I'll go using the first one mostly. But the whole framework and the infrastructure and the setup can be used for like a much simpler use cases as well. For example, when it's only documentation, there are no source code. We can use the same setup, and it will come with the benefit that all the styling, all the user-facing end of it will look very similar. So the users are not having like this multitude of experiences. If they go in one website, it's because it's a documentation, it will look totally different than if they go to a tutorial website, which is still a documentation with some examples, but then it will look different. So no, everything looks the same. Without us having to develop a lot of CSS. Okay, so this is like a collection of notebooks in Python. We are hosting it on GitHub. It's open source, but it's not a community project. So we are adopting a lot of best practices coming from the community open source world, but not everything. So all of our developers are in-house. Our governance is we are not doing like an open source, so open to everyone governance, but we do our work out in the open. We do our work in a pull request-based workflow. We do branch protection, so no one is pushing any code without testing it. Everyone has to go through CI/CD. We are not pushing manually any deployments. And we have and use the open and public issues and discussions, so nothing is really hidden inside a local Jira or some other like closed off system. So everything is really open, and our end users can interact with this repository. And so we are building on the Jupyter book ecosystem, and that we are inheriting a lot of the best practices from the big libraries, from NumPy, from NetworkX. There is some personal overlap, but it's also like good practice that it's like a bigger project figured out. A small group of like local group doesn't have to reinvent the wheel. And it took me a while, but I was strongly advocated for the task-based notebooks, and now it's like not questioned anymore. It provides a really, really good repository hygiene. The repos and your Git will never blow up because you are not accidentally adding binary outputs. So, and the text-based, I can't emphasize it enough. It's really nice for reviewing code and treating the tutorials just as you would do with the library code and do line by line reviews. Okay, so how does it look like? It's a GitHub repository. We have a tutorials directory. That's where most of the content goes. The rest is the scaffolding, mostly the scaffolding, lots of CI config, some things for the websites and our custom plugins. So this is inside. So it's a collection of notebooks here and also a landing page. So all of these markdown files is a notebook itself. How does a notebook markdown differs from simple markdown? So there is a front matter in these markdown files. So with the Jupyter-based front matter, you can specify the format and versions, and also with the kernel spec. So those will be the two fields that Jupyter Lab or Jupyter Notebook would pick up. And then suddenly this is not a markdown file anymore, but it's a notebook. So yeah, so in the rendered version, once it goes through this Mist document engine, it will be a really pretty website with a lot of nice functionalities like hover over links and DOI reference resolvers, really nice references at the bottom, all of those coming out of the box from the engine, from the ecosystem. You don't have to do anything on your end as an author for these notebooks. So this is our landing page with these 5 notebooks listed in the directory. Let me see. This is then how a notebook look like in the rendering. So there is a download link where the user can download, and it will be a notebook. They can also launch it, and it will be somewhat interactive on Binder. So it will work for the notebooks that are having real simple dependencies. Then we are actively working on a Jupyter Lite option where it will run in your browser. That's a little bit experimental at this point. And then this is how the same thing will look like in Jupyter Lab. And when I have those 2 or 3 simple dependencies installed, I can double click and it opens up just as a notebook. So this markdown file here will open up as a notebook. So the end user doesn't even need to know that it's a different format. Usually they are at first, when they're running into like text-based notebooks, there is a little bit of confusion that, oh, it's not called IPNB, where are my notebooks? But once they are through that, the psychological barrier, they are very happy to work with these markdown files. And so how the development process looks like from the maintainer point of view, well, it's the very same as it is for a library. So there is a small change here, a very typical maintenance item. We need to update one of our dependency. It's a pull request. It's an open pull request. Comes in with a little bit of a description, labels, interaction on a pull request, so lots of comments and reviews. And for each and every commit, there is this matrix of CI matrix that pops up. In our case, we are testing with a couple of Python versions, testing on these 3 main operating systems. And there is also a link to the rendered version, a preview, how it would look like, the tutorial. And when everything looks good, then we can go ahead and merge it. And this case, it wasn't everything fine, but we understood what's the problem with the failing CIs, just as you would do in a library. So we merged it anyway. And this is how the diff look like. It's very similar as in the library experience, but if you ever looked into or try to interact and work with a JSON notebook, a JSON formatted notebook, you know that it's really complicated and not convenient, not complicated. It's not convenient, and it's very error prone to manually edit it with a text editor. So if you're a developer or if you are trying to do this on GitHub, It's failing more often than not. And you're going into like this endless cycles of fixing up JSON syntax. So instead of doing that, this looks like a code. There is a code cell. It shows that's how you specify a missed markdown of, okay, here is a Python code snippet coming, and then you just edit the Python, or you edit the markdown, the narrative. It's really super nice. I can't recommend it highly enough. And at the merging, it's just the same as you would do for any libraries. You merge it, and then there will be an action that is pushing that deployment. So you don't do anything manually. If all the tests and all the jobs are green-lighted, it will be deployed to the website. It will be deployed if you are using these tutorials elsewhere in a science platform, in our case. So once everything is fine, it got deployed, and it will also show up all of those other places. So for next for us. And with this, I would conclude the talk, and we have, I believe, plenty of time for questions, and I'm more than happy to have go-backs or show more specific details in the repositories. So thank you.
That's great, Brigitta. Thank you very much. Let me just put these links in the chat one more time. We have some questions already, but if people want to add some more, we'll see what we can get to. And so let me scroll back and find them. The slides are already available, and we will add the recording as well shortly. So that's the first question that somebody asked. There's a couple of questions here about sort of specific tooling, and I realize you may not have direct experiences, but maybe you can talk to the general picture of things. So first of all, what languages do you recommend for Jupyter notebooks? Python, Julia, R, etc.?
So I have first-hand experience with Python only, but everything that I said here should be applicable in other languages. And Jupyter has a very large user base for R and Julia as well. So all of those should work. I don't necessarily have like a comparison that why choose Jupyter rather than RStudio or some R-specific framework. So if the question is about that, then I don't have an answer. But in theory, Jupyter supports not just these three, but also a lot of other languages. So all of this I was talking about should be readily available in other languages. I think the only difference would be, let me see. So these code cells on line 392, it says IPython, and it will be, I believe, Julia. But as you added these notebooks, you will be able to select which kernel, which language to use in Jupyter itself. And once that syntax is figured out, then you use the same in the notebook.
Right. So your premise is essentially that any text-based notebook should work as long as it supports the languages of interest.
Yeah, as long as you have the kernel available in Jupyter itself. So here, okay, let's go back to, okay, so we have the tutorials. And for each tutorial, we are having a statement at the top of the tutorial, but that's like a very specific to us approach of what dependencies we are using. And this is Python. And then in the CI setup, we are picking up, okay, that file is not listed here. But we have that as a dependent. Let me see. Do you see that I'm switched to the repo now?
Yes.
So in the repository, we are so setting up the CI in a way that we always set up with Python. But if you have a way to set it up with Julia or with R, you will have a requirements file, you will install it. And if that kernel is available for your Jupyter as well, so you install it as a kernel with those dependencies, it should all work. So there, it was nothing Python specific here, except that we will use Jupyter-text. So in the rendering step, we rely on a little bit of Python, but it's not for the content.
Mm-hmm. So another specific tool-specific question is about Marimo notebooks. Do you have any experience with those or any familiarity?
I have the familiarity of, there is a company behind Marimo, and that was basically why I said that we went with Jupyter and Jupyter-book, because it's part of a community effort and a community ecosystem. So we still have our tooling, we still have the community. If the smaller companies behind Jupyter-book are out of the game or decide that they stop maintaining or developing it, it's still a live project. On the other hand, if the company behind Marimo decides that, okay, we are not interested in anymore in this, then you are on your own. And it's we really just believe in this open source ecosystem, and yeah, and the work, the collaborations and the community that's behind it. But again, many of these steps are applicable for Marimo notebooks as well. So yeah, those should be able to, you should be able to plug it into a CI system and do the same as you would do with the library. Make sure that those notebooks are working on Windows if you're supporting Windows users, because most of us developers didn't touch a Windows computer in like 20, 30 years, but our users are there. So it's not fair to say and then that, okay, I don't do that, because you are interacting with a college student who will only have like a Windows computer. So yeah, so I firmly believe that a lot of the items in this talk, like the preaching part, is applicable for any other flavor of notebooks. And yeah, test it and test it widely. It's not just on that one job that does the deployment and call it a day, or it works on my system, but test it in a more generic way.
Yeah, and related to the testing, there's a question, sorry if I missed this during the talk, but to what extent are the notebooks being tested? Does the CI just test that all the cells run with no issue, or does it go deeper, such as testing correctness of cell outputs?
Yes, so currently we are testing for it runs, and then we are failing on any regression. We are using PyTest and the PyTest framework, but because there is no output in these notebooks, yeah, we not yet test the exact results. But in theory, that's possible. So I said that the outputs are not stored in these notebooks, but the Jupyter-book uses a caching mechanism. So there are ways to do an actual comparison test. We are just not doing it yet.
Mm-hmm. All right. So there's a question here that I'm not sure I understand, so the person who asked this might need to pipe in, but it says, I wanted to get a hands-on or otherwise example on building unit tests and, if possible, integration tests for a new project adopting CI/CD best practices via the GitHub ecosystem. So it sounds to me like they're asking for general recommendations, and I don't know if you have anything to offer or if the person wants to correct my interpretation.
Yeah. don't know if there is any correction there.
Hi, David, you were perfectly fine in interpreting that. Like, so I come from mechanics, code writing kind of backgrounds, and I'm having some trouble importing my code to smooth CI/CD kind of a pipeline. I have transferred the code online, but as I keep developing it and my collaborators develop it, so how can I think about what could be a good unit test for a variety of the subroutines? Is there an example, just one example you could point to, like being developed by a national lab or a UW or a university or like that, which recently transitioned to something like that or started and I could look at something? It's just that I understand that there are certain values that could be checked, but yeah, I'm thinking too simplistically or something like that, I believe. Looking at some examples might help. I don't know.
Yeah, I would say that it's always a good example to go to a library and then check it while they're doing it. So very typically, if there is a function or a method in a library, then you write a really like a one-liner test that calls that function. You can parameterize it up. So it takes like 2 parameters, then run it with different inputs for those parameters, store it in a variable, and then do assertion on it. So you know what the expected output is. Like the answer is 42, and you say assert this variable equals 42, and then you get a failure if it's not true anymore. So that's one way. I'm also using doc tests and also with the tutorials. Basically, every code cell in these tutorials are treated as a unit test. In the strict definition, these are not unit tests because they are not testing like a small unit in your software. But these are more like integration tests. Like there is like too many moving parts and too many dependencies. But in practice, let's go to, I think it would be the easiest, simplest if to show. I'm showing you. Let's see what's going wrong here. So look at the log. There'll be some server-side nonsense, which is expected because we are reaching out to the server so often. That's one limitation of our system. So if you look at this, so this is one tutorial, that SIA version 1 Cosmos, and all of these code cells are treated as a unit test. So using PyTest, using the very same tooling that you are using for a Python library, use PyTest and some PyTest plugins. And then these will be like individual unit tests. And if going to, let's go back. So in practice, this cell here, that will be one unit test. And this will be another. And if you are thinking about real unit tests, then at the end, you could say like assert. Oh, okay, assert. We still haven't done any calls here. Okay, assert results equals 42. And if it's not true, then you will get a failure.
Okay. So just to summarize, like if we have like what do you call analytical solution or a simpler solution which we know exists, and verify the numerical solution with that for that simple case, that could be a good starting point, right?
Yes.
Okay.
Yeah. Or you can write up like mock outputs. You can write up. You can test like there is a figure at the end, so you can put down this figure either with a hash. It will be painful because then you expect like pixel perfect matching. But there are also ways to have like figure testing when there is a little bit of like a leeway, how different they could be. But yes, you are storing the expected value somewhere, and then you are testing against that value.
Okay. Thank you so much for your insight. Thank you.
Yeah, so one more question. I do have a hard stop at the top of the hour. I apologize to everyone. Historically, investments in reproducibility infrastructure have been underfunded and insufficiently incentivized, at least for communities I know. In particular, publishers have not demanded reproducible results for publication. Does your community do a better job at reproducibility? Your efforts seem to indicate the value of reproducibility by virtue of the investments you make.
Yeah, I don't know how optimistic or pessimistic I can be here. I think astronomy might be a little bit easier than like in biology. We have only a handful of major journals. Our data is not coming from a lab, but from big infrastructure projects, and usually our data is also open. So we don't have many of the problems as other fields. Anyone, in theory, anyone can go there, come to our data archive, download the same data and try to reproduce it. Now there is no enforcement on it. So as far as I know, none of the journals are enforcing to submit a notebook or submit any software that does the full end-to-end reproducibility. But in our field, I think it's less and less acceptable to not share the code as well. So it's still the case for like a Nature papers, you see that the code is available on reasonable request. What is reasonable request? But in other places, the journals already require you to cite the software you are using and maybe also share the software you are using. So I think those are like baby steps. So we are getting there. It's still very far from like a fully reproducible scientific result. But I think it's getting there. And I believe that us as national labs or us at the NASA data centers, we can show the way how to do this. So that's why also I'm very strongly advocating of doing all of this out in the open, even if all our contributors are inside, all of us are colleagues at the same place. We still do this work outside. It's not like we are developing inside and then once a year there is a big code dump. But the whole process is out in the open, and I think slowly that might changing the approach of how it will work. But I think it's a very slow process, and we are still at the very beginning.
Great. Thank you very much, Brigitta, and thanks everybody for attending. We'll look forward to another webinar in a couple of weeks. It's a little sooner than we usually have, so just don't be surprised to, you've probably seen the announcement already. And so we'll see you in early September. Thank you all very much. Goodbye.